Hey everybody, it's Mr. Carr again. Today we're going to be looking at 9-3 day 2. We're going to continue our work with our polar and rectangular coordinates. So we're looking at converting between polar and rectangular equations now. So not just coordinates, but whole on equations. So for our first one, we're going to look at identify the graph of x plus 2 squared plus y squared equals 4. Then write the equation in polar form and support your answer by graphing it, the polar form of the equation. So this is going to be a circle. We see that it's in that format there. It's got a center of -2, 0. And because of my r squared is equal to 4, that means my radius is equal to 2. Now remember, for before, we established that x is always equal to r times the cosine of theta, and y is equal to r times the sine of theta. So that means that if I look at my normal setup of this in this format, I can replace my x and my y with this. So that's how I'm going to get the polar equation. So that'd be r times the cosine of theta plus 2 squared plus r sine theta squared equals 4. So now I can do, if I multiply this out, this needs to be expanded out. So it's going to be multiplied 2 binomials then. That will be r squared cosine squared theta plus, it's going to be 2, there's going to be 2 of these because remember with the distribution, they'll end up being 4 times r times the cosine of theta, plus 4, and then plus r squared sine squared theta equals 4. Okay, so now I'm going to try to simplify this as best as I can. Notice how I have 4 and 4 are going to cancel each other out. I can put together these and these. So when I rearrange that, I'm also going to factor out an r squared. So when I do that, it looks like this: r squared times cosine squared theta plus sine squared theta plus 4r cosine theta is equal to 0. Well, now that's equal to that, remember what this is equal to. That's our Pythagorean identity, so that's just going to turn to 1. So this will just turn into an r squared now. So r squared plus 4r cosine theta equals 0. If I bring this to the other side, so I got r squared is equal to a -4r cosine theta. I can actually just divide both sides by r just to make it as simple. Like I want to get r squared down to an r. And thankfully, these are in common. So that means r is equal to -4 times the cosine of theta. Doing that as a polar coordinate grid, basically we're saying here that you would go here to this spot, -4 cosine theta, you would plot those points around. It would go around like this here for the graph. It would do this for my polar coordinates. So that's just practicing what you've done before in that case, just to confirm it. Okay. So next one, identify the graph of x equals y squared. This is a horizontal parabola. Okay. So what that means is, again, we're going to use the same ideas of x and y. So I know that y squared is equal to 1x here. If I think about it in terms of what the parabola is going to look like, I know that 4p is equal to 1. So if I divide by 4, that means my p is equal to 1/4. This is what we've done in the past. But now let's talk about in terms of our, sorry, identify the graph. So let's go ahead and graph it real quick just so we can see that real fast. We know it's going to be at the origin for the vertex. We have p-value of 1/4. So if we go 1/4 out, ends up doing this for the equation here. Okay, so 1/4 right here with our last rectum like that. Very small. Not going to worry about that as much right now. But if we use our x equals r cosine theta, y equals r sine theta, those are both going to be replacing this and this. So that means I have r sine theta squared is equal to r cosine theta. Okay, so if I multiply that out, that is r squared sine squared theta equals r cosine theta. We have extra r's here, so let's go ahead and divide that out so it gets rid of one of these, and that one's gone then. So that means r times the sine squared theta is equal to the cosine theta. And remember, with our polar equation, we want to get this equal to r. So I just divide both sides by sine squared theta. So what that means is r is equal to the cosine theta divided by the sine squared theta. This, if you graph this in your polar form on in your TI-84, you're going to get the same thing as this horizontal parabola, as if you did it as this version here. Okay, so just keep that in mind. That's what we're doing. We're making connections between the two versions here. Next one, write the equation theta equals pi over 4 into rectangular form, and then identify its graph. So remember from before as well that the tangent of theta is equal to y over x. So in this specific case, we're saying theta equals pi over 4. So that means that the tangent of theta is equal to the tangent of pi over 4 in this case. Okay, so we're basically just replacing this with the pi over 4 here. So in this, sorry, since my theta is pi over 4, we're saying that tangent theta is equal to the tangent of pi over 4. Well, this tangent theta is y over x, so I'm going to replace that with y over x now, equals the tangent of pi over 4. So the tangent of pi over 4, well, sorry, should have done that. Makes it easier if I do this. Remember, tangent of pi over 4 is this right here, 1, 1, and root 2. Tangent's just 1. So that means the tangent of pi over 4 is equal to just 1. If I multiply both sides by x, I get y is equal to 1x, or y equals x. So on a polar grid, it looks like this. It is just a straight line. And that's what we've done before. When we graphed our polar equations, just theta equals pi over 4, we get that straight line. So now we can kind of see why it's also doing that too. It's that straight line is related to the equation y equals 4 in this specific case. Okay, polar equations here, we got r is equal to 5. So if you remember what that one looks like, r equals 5, we know it's going to go out to, well, it's going to go beyond this, so it's got to go out to 5. We'll just say it's out here. And then it does something like this, right? Close enough on that one. So if that's my r equals 5, we know it's going to be a circle. So how do I get that from here? Well, if r equals 5, remember that r is equal to the square root of x squared plus y squared. That's what we did when we solve for r. So in this case, 5 is equal to the square root of x squared plus y squared. How do I undo the square root? We square both sides. So 25 is equal to x squared plus y squared. And that's my rectangular form, which makes sense because that's my origin is at 0 with a radius of 5. Okay, one more example to do. Write the equation r equals 2 times the sine of theta in rectangular form, and then identify its graph. So in this case here, if r is equal to 2 times the sine of theta, and then it gets a little bit tricky here, but the idea, one of the things we want to remember is that y is equal to the r times sine theta. That doesn't quite look like this version here, but if I do this, if I multiply both sides by r, so r squared is equal to 2 times r times the sine of theta, now this looks like that. So I can replace this r sine theta with a y. So I'm going to have a 2y over here. But with r squared, well, remember, r is equal to the square root of x squared plus y squared. And if I square these, that means r squared is equal to x squared plus y squared. So I'm going to replace this r squared with this. So x squared plus y squared. Now, normally we don't like writing our equations like this. So I'm going to go ahead and do x squared plus y squared minus 2y. Notice how it's looking like it might be a circle here. So I'm going to do completing the square. So I'll do plus blank is equal to 0 plus blank. So if I do completing the square with my -2, remember that's a -2 over 2 squared, which is going to be positive 1 here. So I'll put a +1 and a +1 there. So x squared plus y minus 1 squared is equal to 1. So what I get is a circle with a center at the point 0, -0, 1, and my radius is equal to 1. As a graph on here, I could do my polar version of this. You're going to get a circle that will look like, it'll be basically here. It's going to just look roughly like this, but it's stretched out because it's a polar. All right, so that is it for today for 9-3 day 2. Again, we're just working with our polar equations and going back and forth between polar and rectangular equations. All right, take care, everyone.